Morning class. Welcome to our today class. I can see Kinsley is present, Impeka, and Mosonic. Welcome to today's class. We are going to talk about control system, and I request that you allow me to share my presentation. So, control systems. In our class today, we are going to do introduction to control system, whereby we will define the basics of control system and the two major modes of control system. So maybe we start by defining what's the two main agendas we're going to discuss today. That is open loop control system and a closed loop control system. Yeah. So we define what's controlling. Controlling can be easily be defined as to cause a machine or a process to function in a predetermined manner. Again, another definition of controlling can be defined as to energize or to energize an output. That is as a result of some consideration done with a controlling device, depending with the input from sensors. Then we can also define a controlling as to set a data table bits to an on or off state of a machine by a user program. So those are the simple definitions of what we can term as controlling. And for us to achieve this, we have to define what's a control system. Now, a control system is a system of devices or set of devices that manages, commands, directs, or regulates the behavior of other devices or system to achieve desired results. A control system is a system which controls other systems. Yeah, so a very simple diagram of a control system. We will have the input, then we have the process that makes decisions, and those decisions are reflected in the output. So the inputs can literally for control. Normally, the inputs are in terms of sensors. Sensors give input in terms of information of the current state of every agent that is being monitored to the process, to the controlling device. Now, the controlling device will make decisions and try to control the output, which are mostly the actuators, which can be either a motor or pump somewhere, and they either turn it on or off. So those are a simple description of what a control system looks like. So control system can either be open loop, closed loop. It can either be an open loop control system or a closed loop control system. Yeah, so the two, I think from the development of control system, the most basic one was open loop control system, whereby it was the starting point before it was developed as need arises for higher accuracy. So we start with an open loop control system because it's the most basic. This is a control system whereby we have a controller and the process with the inputs and the output. So in this process, the diagram will only have an input that gives information to the controlling device. The controller will do some considerations depending with the program that is in the controller. Then it will make decisions. After making those decisions, they will be communicated to the actuators, which are the output, and the desired effect will be vectored with the actuators. The actuators can either be a motor, a pump, or anything that is used to do the actual job. A control system in which the output has no effect on the control action is a mode that we call is open loop control system. It does not provide feedback for the actual state of the system. So whichever the result is after the actuators have been directed to effect a certain state, the output of that is not measured so that the next time the decision is made is adjusted to fine-tune the effect. So it's an open loop control system whereby we don't consider what is the result of the actuator as a result of being monitored by the control system. There's no comparing of output with the input for control purposes. The action is totally independent of the output of the system. So applications of open loop control system, we have an electric hand dryer. The way an electric hand dryer works is that when you put your hand below the hand dryer, it will sense your presence and then it will blow hot air to your hands. So this one is not The hand dryer doesn't take into account whether your hands are wet or not. So long as there is presence of hands, it will blow hot air. So that one, it means that it doesn't consider that your hands are either dry or not. So it means if at all you put your hands on a hand dryer and they are completely dry, still the hand dryer will blow the hot air, intending to dry the hands as much as they are dry. So that's one example of an open loop control system whereby the output doesn't is independent of the input. So another example of an open loop control system is an automatic washing machine whereby the machine will wash a specific cloth using a preset time, whereby as long as the machine has run for that specific time, it is presumed that the clothes have been cleaned, whether they are clean or not. So the machine doesn't take into consideration to check whether the clothes are clean for it to stop washing. So that's another example of an open loop control system. Another one is a bread toaster, whereby the toaster will toast bread at the specific for a specific duration. It doesn't consider whether the bread has been properly toasted or not. So as long as the time has the toaster has run for a specific time, it will stop whether the bread is toasted or not. So another one is a coffee maker. It will make coffee for specific time. So it will not consider whether the coffee has been fully cooked or not. It will stop so long as the time it was set has been run down. So another one is a time-based control dryer. The same thing happens. It will dry the clothes using a preset time. So all these examples are the kind of appliances we use at home, and we can directly see how open loop control system works. And these are the devices that don't really measure the output so that they correct the input to fine-tune the results. So these open loop control system have advantages and disadvantages. We start with the advantages. So the first advantages is that since they don't have a feedback, they are very simple in construction and design. They don't really entail much. Number two is that they are economical. They don't cost much. It is easy to maintain because of the simplicity of the machine. They are generally stable because there is no too much considerations. They are convenient to use as output is difficult to measure. So as much as they don't achieve a lot of accuracy, it's convenient because at the end of the day, some applications don't require that much accuracy. Disadvantages of a open loop control system is that number one, outrightly they are very inaccurate. That's number one. They are not reliable. They can lead to wastage of resources, whereby, for example, a hand dryer drying hands that are already dry, that's wasting resources. Then another disadvantages is that any change in output cannot be corrected automatically. That is due to the absence of the feedback. So it means that whatever the output is, the machine will keep on doing the same actions without really determining whether whatever it's doing is really achieving the desired results. Then the other disadvantage is that they are slow generally because of the issue that they don't really take into consideration the state of the output before they make the other decisions. So that is what we have for today. So maybe for an assignment, is that for you to go and make notes on closed loop control system, and we will discuss about it on our next class. Thank you and see you in the next class.